Hi everybody, we are going to start talking about energy types. You'll want to at least write down the definition of each energy type, and I have underlined that for you in each slide. If you want to draw little pictures to help you remember, that would be great as well. So here we go. Okay, our first type of energy is thermal energy, and that is simply the total kinetic energy of all the particles that make up an object. It's also known as heat. Okay, one thing to remember is that thermal energy does move from warmer objects to cooler ones, okay, or from faster moving particles to slower moving particles. Kind of think of it like the Tasmanian devil. When he whirls into a room, he's going to bump into other particles and their motion will speed up as well. Okay, faster particles equals higher temperature, and thermal energy can be created in a variety of ways, as you will see here. Okay. The next type is chemical energy. This is the energy required to bond particles of matter together, and there's energy stored in those bonds. So I'm sure you've heard of, for example, a water molecule, H2O. Okay, that means there are two hydrogens and one oxygen, and the oxygen has to be bonded to each hydrogen atom. So there's energy in that bond, and we will be talking much more about that later in the school year. Chemical energy is often referred to as potential chemical energy because it's stored in those substances. So examples: oil, gas, batteries, food. Every time you plug in your cell phone, okay, you're trying to charge the battery. It's holding energy in the battery to be released at a later time, okay? And here's a wonderful looking breakfast over here. That breakfast doesn't do you any good until it's in your stomach and your body has started to break it down and get the energy from the food into your cells so that you can then change that energy into something else. Okay? Next one is electrical energy. This is the energy of moving electrons, so that should be fairly easy to remember. This is usually through a wire. And the thing about this one is it can produce many other forms of energy for us. So I just thought about probably the most common ones that you might use would be batteries, and you can kind of see the direction of the electrons flowing once you have a closed circuit. Okay, and then we have a hairdryer. So what type of energy is this going to create for you once you plug this in? It's going to create heat. It's going to create motion. Okay. And also probably some noise, right? Over here we have a sad little frayed charging cord. Okay, we don't want that to happen because then that disrupts the flow of electrons. Okay, and a toaster. Think about what types of energy a toaster ends up producing. Okay. Sound energy, simply energy caused by an object's vibration. So I have a guitar great here. His name is B.B. King. He strums the guitar. The vibrations that you can see in the middle GIF here affect the surrounding air, which sends out sound waves. Once it hits our eardrum, that's how we end up actually hearing those sound waves. And then our brain processes it as well. Okay, but definitely sort of a transfer of energy here. Now, one thing to think about, is sound energy usable? It's debatable. If you hear the car tires screeching on the road, that's going to alert you. But can you take that energy and then use it elsewhere? You'd have to have some pretty fancy equipment to capture that. I don't think it's quite usable in terms of causing other work to happen. Remember, energy is the ability to do work. Okay? Next one is light energy, and this is produced by vibrations of electrically charged particles. So light is kind of goofy, and we will go into more detail in this later, but it is both a wave and a particle. Okay, definitely comes from the sun, of course. Also, there are some chemical reactions which produce light. I mean, if you've ever witnessed a campfire, then you should be aware of that. If you love atoms, which eventually we will be talking more about, what happens is electrons can be at a really high energy level, and if they fall down to a lower level, like it's kind of illustrated here, what happens is light is given off. Okay, so that's actually how fireflies light up their rear ends. Okay, again, This is all coming in the later half of science this year. Next one is nuclear energy. This is simply energy stored in the nucleus of an atom. Once it's released, it can be used to power homes, buildings, etc. It's actually very clean energy. It doesn't produce a lot of carbon emissions or anything unless the whole entire plant, breaks down. Then that can be dangerous, and that has happened in our history. But it is one of the most efficient types of energy. I do have a link here for you. This is just an article. It's not a text, but it is pretty interesting. That's actually where I found these two images. So there's two types. Nuclear fusion. So when things fuse, they come together. Okay, so we actually have two types of hydrogen here, deuterium and tritium. And when they fuse and come together, now it has two protons. You see the pluses, those are protons. You don't have to remember all of this until later when we get to atoms. But now it has become helium, and you have a free neutron floating around. Neutron is not spelled right. But that will give off some energy. Okay. The opposite also gives off some energy. I would argue that this is maybe a little bit more. So if you have a neutron right here, it bombards a nucleus, uranium nucleus. And so this is fission. So that splits into two. Now we now have two separate products here, and that releases a ton of energy. And here's the thing. It then allows for, it actually says right here, a chain reaction. So lots of energy is released once you start splitting the atom. Okay? I believe that's the end of section 2. So that's just a sort of an overview of the different types of energy, and it's certainly not an end-all. It's not a complete list, but it's the most important ones for you right now. Let's move on to section 3 because it's fairly short, and it makes a lot of sense to just finish that right now. Okay, so energy conversions are, I don't know where to put myself here. So this happens when there is a change from one form of energy into another, often by a machine. So I have several examples here for you. The sun hits a solar panel, so we have light energy hitting a machine, which converts it to electrical energy, which that's a real messy electrical situation. But once you have electricity, you can make what? Almost any other type of energy. Okay, you can plug in your cell phone, you can turn on a blender. That will create motion and noise. Okay. Once you have electricity, alrighty, the electricity could be feeding into your television. What type of energy does the television produce? Sound waves and light waves, and probably something else. Probably some heat. We have electricity going and powering a fan. The fan will produce kinetic energy once it starts moving. Okay. One final note, I'll move myself up way out of the way. Some energy is always, quote, lost as heat when energy is converted from one form into another. We say it's not actually lost. It's not like it doesn't exist. But it's lost to the surrounding air and isn't really that usable again. Now, there have been some inventors trying to capture some of that heat and to use it to kind of basically funnel it back into the machine, but it's really hard actually to do that. Think about when you charge your phone for a while. How does your phone feel? Or think about, watching TV for a while. If you go up and feel your TV or the computer, it will feel warm because of all the energy conversions that are happening. Okay? Again, it's not completely lost. It's just that it's not that usable. All right, energy converters. You are an energy converter. You have a ginormous breakfast. I wish I had time to eat that in the morning. I just don't. But once you consume that, okay, this energy in there is going to power all your movements in athletics. It's going to heat and warm up your body. The red areas are the parts of the body that are kept pretty warm because they're the most important parts, right? There's a reason the center of your body should be warmer than, say, it's really easy to get your fingers pretty chilly because I hate to break it to you, they aren't as important as what's in here, okay, and in here. Also, anything you do, talking, listening, thinking, muscle repair, digestion, movement, breathing, all the things you do, you can do those because of the types of foods that you put into your body. Now make sure you're choosing good foods, okay? That's my little spiel there. One last concept for you, energy efficiency. You may have heard commercials for getting more efficient windows or a more efficient vehicle. So this compares, in a nutshell, this just compares the energy before a conversion with the energy after it's been converted. Now, a typical vehicle, okay, look, is only about 33% efficient. Here's why. If you're starting with diesel, okay, about 33% of the energy in there once it's combusted is lost through exhaust. About 24% is lost to coolant. About 5% is just friction between the wheels and the road, and it's radiated off or if you feel the hood of the car, it might feel warm. 38% goes to the engine. So as far as motion, the function of the car is to get from point A to point B. Only 33% of that original 100% goes to moving the vehicle. So it's not actually that efficient, okay? So anyway, that's just one last basic concept there. Sorry for the long video, and we'll see you in class.